Welcome, everyone. My name is Michelle Thatcher. I'm the CEO and co-founder of the U.S. Green Chamber of Commerce and the creator of the Global Climate Pledge. Today's program is What Makes a Good Climate Goal? Critically evaluating campus plans for climate action. So I'll pass it right on over to Hadley.
Yes, thank you, Michelle, for that introduction. My name is Hadley Wilman, for all of you who do not know me, and I am the director of the University Climate Ambassador Program at the Global Climate Pledge, and we are hosting this webinar as part of our ongoing series. And so if you are passionate about sustainability on university campuses and you're joining us for the first time, you can keep up to date with us on the Global Climate Pledge website or on the Eventbrite through which you registered for the series. And at the Ambassador Program, our goal is to connect students between campuses and as well as faculty and staff within a campus and between campuses, and to share strategies to accelerate change for a greener future. And at the same time, we want to connect with industry stakeholders and experts like the wonderful speaker we have here today, so that we can educate students and faculty and staff, and especially our students, so that they feel confident to go and pursue bold change on their campuses. And so with that, I am very pleased to introduce Amanda Smith, Senior Scientist at Project Drawdown, for her presentation today.
Great. Thanks a lot, Hadley. I'm really happy to be with you all today. I appreciate the invite. I think this work is really cool. And what I want to talk about is what makes a good climate goal, with the idea of sharing how can climate goals on campus drive important actions that help with climate, with building a better world for all of us. So I want you to leave feeling empowered that you know how to talk about what goes into a good climate goal, and that you know how to ask good questions about that. So we'll talk about the big picture of climate and emissions, make sure we're clear on some key terms. We'll look at what makes a good one, and then walk through the specific elements that should be there. And you can do this with the climate goal that you'll look for your campus or organization. And then we'll discuss our findings, learn from each other, and understand how campuses are currently expressing their climate goals. So I work for Project Drawdown. We're a nonprofit organization that seeks to help the world reach drawdown, essentially the point in time when we stop making climate change worse. And we'll talk about that in just a few slides. So we've been recognized as the world's leading resource for science-based climate solutions. And we provide information for students like you, for corporate leaders, investors, policymakers, community organizers, educators, and activists on what makes for effective climate action. So our focus today is on the campus, but the principles are generally applicable to any collection of buildings and facilities. So I saw that some of you are not university students. Really glad you could join us. But I want to take a brief pause here, and I want you to think about whatever campus you're going to focus on today. So it could be your university's campus, or a collection of buildings that's familiar to you. You can close your eyes if you want. Think about, what does it look like? What are the smells that are there? What are the sounds around you? I want to keep coming back to your campus and your experience as a touchstone, because what we're really talking about is the places and the people that matter to you, right? And how do you care for them at your university? And how do we extend that to caring for the whole planet? So my focus is on buildings and energy systems. It's stuff like this. Climate goals, of course, can be much broader than that. But most of my examples will relate to buildings and energy use. And your campus likely contributes to greenhouse gas emissions in a number of sectors, but you certainly have buildings there. So the principles, again, are applicable broadly. Just know that I'll be drawing examples from what I've learned and where I have expertise. So let's begin by making sure we have the same basic understanding of the relationship between emissions and the climate. And I'll talk to you about how we think of it at Project Drawdown. So drawdown itself just refers to the future point in time when levels of greenhouse gases stop climbing and start to steadily decline. That's a critical turning point for life on Earth. So our mission is to help the world reach drawdown as quickly, safely, equitably as possible. And here's the basic framing for how we think about this. Before I give that to you, I've got to jump in and give you our first piece of lingo, which is called the carbon dioxide equivalent. And it's the unit that we use to do calculations involving different greenhouse gases. Now, why do I care so much about units? Well, I used to be an engineering professor, but it really matters here. Okay, what we're going to be doing is accounting for greenhouse gases that are emitted by humans. That's part of any good climate planning. So let's look at what those gases are. CO2 from burning fossil fuels is the biggest contributor, as you've probably heard. CO2 is just the chemical way of expressing carbon dioxide. And there are other sources of CO2. And there are also other substances besides carbon dioxide that will affect global climate change. So CH4 is the way we express methane, nitrous oxide. And the deal is some of these other gases are actually even better at trapping heat than carbon dioxide is. So as an example, let's look at this top sliver called F gases, okay? It's not a dirty word. Those are fluorinated gases. That means refrigerants. So most air conditioning units, most heat pump units are using these type of substances. And a kilogram of a refrigerant will cause thousands of times more global warming than a kilogram of carbon dioxide. So if I made a pie chart and it only showed the kilograms emitted per substance, you wouldn't even be able to see the slice for F gases. But in reality, these are making a meaningful contribution to climate change. So how do we get this pie chart, which has contributions from different substances? Well, the way we do that is we use a CO2 equivalent. So that's used to lump different greenhouse gases together. What happens is other gases, so not carbon dioxide, get normalized to carbon dioxide, since that one's the biggest contributor, right? And so for each gas, the physicists look at how much warming would this cause relative to CO2. And then because different gases will have different effects on the climate and they will stay in the atmosphere different lengths of time, we also need to specify what's the time period we're using to normalize against CO2. So the most common one you'll see is a 100-year time horizon. That means over 100 years, how much warming would a gas cause relative to CO2? There are other ways to do that conversion, which we won't cover here. The takeaway that I just want you to understand is converting to a CO2 equivalent allows us to do calculations with different greenhouse gases together. Just makes it apples to apples so we can see the whole big picture. And then all the material I'll show from now on, not from now on, but in these this next series of slides with a black background comes from our Climate Solutions 101 course. They were organized by my colleague, John Foley, and I'll show you a link at the end where you can access this if you want to dig into it. So let's think about this idea of achieving drawdown. Imagine this gray rectangle is the greenhouse gases that humans are putting into the atmosphere every year. Okay, so the left side of this diagram shows where these gases come from. These are sources of greenhouse gases, of heat trapping gases, and they include electricity production, food, agriculture, and land use, industry, transportation, buildings, and some other energy related emissions. And these here are global numbers because we do ultimately all share the same atmosphere. The numbers for your campus will look different, but I am confident in saying that each university system is going to have some contribution to emissions in each sector. And then note that the emissions are attributed here based on where the gas is entering the environment. So I want to look at the contribution of buildings because it's my area of study, but also you certainly have multiple buildings on your campus. This is showing that 6% of emissions globally are happening directly at the building site. This is boilers, water heaters, equipment that's burning fossil fuels right there. But buildings are also tied to all of these other sectors where emissions are happening. They're consuming electricity. They're where we consume most of our food. They're constructed from products made in industry. We have public transit and private cars integrated into our built environment. And we have some other energy related emissions. So for example, that could be taking place in the oil and gas sector. Know that natural gas has emissions associated with it before it even gets to a building to say be burned in a boiler. So that's a lot of different places we are adding greenhouse gases to the atmosphere. And there's a lot of ways that buildings and campuses can be sources of greenhouse gases. Thankfully, this story doesn't just end there. Nature is doing us a favor. And what's happening now is about 40% of the greenhouse gases we put into the atmosphere are removed by our lands and oceans. So we call those natural carbon sinks. But almost 60% of what we're emitting is left behind. So this is where we're creating this thick blanket of heat trapping gases over the planet. And understanding where the gases come from on the left and where they go on the right helps us to identify like what's the suite of climate solutions we can implement to get those levels of greenhouse gases in the atmosphere to stop climbing. Reducing our current sources of emissions, making the left side smaller is the most important big thing we can do right now. And that's true for your campus too. Okay, so I want to give you a little bit more lingo that relates to our climate goals. The first one, I'm sure you've heard about, let's talk about net zero. But we want to start by considering this concept at the planetary scale. Okay, so if we look at our emissions trajectory, here's the trajectory we're on. The dot is now, right? And now we have a scale on our graph. It's gigatons of CO2 equivalent. That's 1 billion metric tons of CO2 equivalent with the conversion done on a 100-year basis. So we could kind of follow along in the same trajectory, or we could take quick action in this decade and implement readily available solutions to curb greenhouse gas emissions. Those are big cuts, but we do have solutions to get us here. It's possible to cut our emissions in half. We keep cutting in the next decade. So the biggest cuts happen now, but we keep going. And we keep going until mid-century when we have very few sources of greenhouse gas emissions left. So at this point, right, we've thoughtfully implemented a whole suite of solutions guided by science. We've done that quickly. We've done that with an eye on equity, and emissions have become very small. Well, what if we're not all the way to zero by 2050? What if we just have a few sources of emissions left? The question is, can we bring the atmosphere back into balance by removing a small amount of remaining emissions? Well, if we look at carbon removal technology, it's really small in terms of what we're doing now. If we did scale that up in a big way in the future, and we were able to remove a small amount of greenhouse gases that we're putting into the atmosphere in the future, then the planet hits net zero emissions. So that means the greenhouse gases we're removing from the atmosphere in green are at least as much as the greenhouse gases we're putting into the atmosphere in red. So net zero means a balance between sources and sinks has been reached. So we're saying the net of the emissions are zero. And we want to get there as a planet by 2050. That only works if we have steep reductions in emissions right now, because we have the benefit of not having to deal with those cumulative emissions. Right, so, and we know that we can't grow carbon removal projects anywhere near the scale of our current emissions. So again, pointing back to cuts that need to happen. So net zero emissions originally was this planetary concept, and others use the same sort of concept and apply it to campuses, cities, or other regions, very specific parts of the planet, even buildings. Net zero can be tough to quantify, and a lot of the difficulty comes in what do you count as carbon removal, right? So remember, we all share the same atmosphere. Our big goal is to drive emissions down dramatically across the planet, make sure that a very small amount of emissions are remaining just a few decades in the future. So I want to pause here and bring you back to your campus. So think of a place that's familiar to you, maybe where you leave or enter campus, maybe a classroom you see often, or a table at the library where you study regularly. I'll give you a few seconds and just picture that. So I'm thinking about when I worked at the University of Utah, I would bike to campus from the south part of, I'd enter in the south part of campus and get this feeling of, oh, I'm on campus now. I'm kind of leaving the city and the neighborhood. Okay. Now, what does that mean? Like, how does this relate to our planetary net zero? Well, one thing I want you to understand is that whenever we look at reaching a planetary net zero and we try to think about how do energy systems need to change, we keep running into the same concepts over and over. So all credible climate plans that try to curb energy-related emissions so that we're limiting global warming to 2 degrees C or less compared to pre-industrial levels, whatever the pathway, they always have 3 elements in common. The first one is save energy, right? That means conserve and be efficient when you do need to use energy. The second one is decarbonization. And the third one's electrification. So these last two pieces of lingo, I want to talk about just so we really understand what do decarbonization and electrification relate to, what are they indicating, and then we'll come back to this and talk about how they relate to each other. So decarbonization is important, but what specifically does that refer to? It's about changing what we're doing so we drive our greenhouse gas emissions towards zero. Decarbonized means not emitting greenhouse gases. So the thing that ultimately will have less carbon in it is the atmosphere. And fully decarbonized would mean that building or campus or sector is no longer responsible for any greenhouse gas emissions. Decarbonization is the processes that are taking us in that direction. And I like to illustrate this with a graph. I did warn you, I used to be an engineering professor. But this is one of my favorite graphs, and a lot of energy nerds really like it too. Here, we're looking at CO2, carbon dioxide emissions that are related to energy use in the US. And it's the same kind of idea. We have the sources, where things are coming from on the left. We have where it's going on the right. And the gray bars, those are emissions. Those are where things are being emitted. And if you look at it, you notice that those gray bars ultimately trace back to natural gas and coal and petroleum, right? So decarbonization is the idea that we move to energy sources that don't create greenhouse gas emissions anytime they're being used. That means shifting, right, from fossil fuels to relying on sources of energy that don't have emissions associated with them. Okay, so shifting to these top boxes is decarbonization. Electrification also gets mentioned a lot when we're talking about decarbonization. Why is that? Well, electrification is about what kind of energy is used to do something. So it's converting devices to use electricity rather than another energy source. A century ago, that might have meant we replace something that's powered by a human or another animal with an electric motor. Today, it really means we're replacing fuel-consuming devices with electric devices. So that's heat pumps for space heating and water heating. That's electric cars, trucks, and buses, electric cooktops and dryers at home, those kind of devices. So to illustrate this, let's look at energy use in the US. So here we're looking at flows of energy. The original form of energy is on the left. It's getting converted to electricity if it's going through that orange box. And we have some end uses on the right. Those are energy services we provide in buildings, energy used to make things in industry, or energy for transportation. So electrification means providing those same energy services with electricity rather than fuels. It's really about looking at the services provided to buildings, industry, and transportation and figuring out how to make changes so that those services are coming from electric devices. That means we're going to shift a lot of energy use, so it's coming through that orange box, right? We want to provide those services through electricity generation. We want to shift how the energy services are being provided. So here we are again. There's three main elements that keep coming up in climate plans for any plan that leads to steep cuts in energy-related emissions. We save energy by reducing energy demands. We decarbonize largely by changing the electric power grid so that we're not emitting greenhouse gases when we generate electricity. But we have a lot of other decarbonization to do as well. And then we electrify. So looking at our end uses, providing more of those energy services with electricity. Now, if the electrical power we're using was generated with sources, then electrifying is also a decarbonizing process. Okay, that doesn't mean we wait for the grid to be fully decarbonized before we electrify, because the lifetime of equipment in buildings or the lifetime of a vehicle can be decades. And we want to take advantage of the fast progress that's happening right now in decarbonizing the grid. We also get air quality benefits of electric vehicles, of electric equipment, as soon as it's deployed. So these three things can happen together because they support each other and they support us. They're interwoven elements that keep showing up in our pathways to planetary net zero. Now, I want to stop and just ask if anyone recognizes the plants in the background here, or if you have any idea why I'm putting plants into my slide. Yes, Patricia O'Donnell. Thank you. Three sisters. It's corn and beans and squash. And they're called the Three Sisters. It's a technique from indigenous American agriculture. And the cool thing is, these plants, if they grow together, provide for each other as they're growing together. So biologically, each one is doing something that helps the others to thrive. In doing this, they provide for us to thrive and to be nourished by the earth. So I learned about this from Robin Wall Kimmerer's book, Braiding Sweetgrass. I definitely recommend checking out the chapter called The Three Sisters. She explains what they can teach us about honoring our gifts, community, and reciprocity. So these are our three interlinked parts of climate strategy that can happen together. Now let's get into it. You have a sense of the climate big picture, and you're familiar with some of the lingo around setting climate goals. But what makes a good climate goal? Thinking back to that campus level goal. Well, the first thing is it has a planetary perspective, and that sounds really big, but what I mean here is it's supporting our big picture goal of reaching planetary net zero. It also respects the bigger picture of why we want to get there. It's about supporting humanity and the flourishing of the natural world. So there's equity and societal improvements and other concerns that are also considered. So we start by acknowledging our desire to contribute to planetary net zero. We want to head in the same direction as the global climate goals or targets. But at the campus level, it might be hard to figure out how do I fit into a global target. So one thing we might do is look at state level goals or targets that your city or your county has set to see how the campus can support those or help coordinate with those plans. Maybe it makes sense to choose a similar timeline or to target particular types of emissions based on what's predominant in your region. But your campus might even choose to go beyond those goals. So there are some states that haven't committed to a binding climate goal. Sometimes the university just wants to do more and be a leader. I believe academia is at its best when it's a place where new ideas and human progress can begin to flourish. Which brings us to a goal that should be challenging and doable. This is the same way we flourish as humans, right? We do new things that are challenging, but reachable. So a goal needs to be challenging enough to push the campus toward meaningful emissions reductions that wouldn't have happened otherwise. And it needs to be doable because we need to have a baseline understanding of where we are now and what are the people and the time and the resources that we need to make steps in this new direction. So I use this picture because it's actually the same idea you have as a student when you're setting goals for yourself. Like before you start a new class, maybe you have a target for what you want to get out of it or the grade that you want to make. You talk to someone who had the class before. You plan out how much study time do I want to reserve every week, right? You probably also, if you have a big goal, are setting milestones for yourself because you want to check whether you're on track. A campus goal is usually accompanied by a plan, and ideally that's broken out into particular steps that are going to drive toward that goal that have some key milestones spelled out along the way. So you want to be able to check if you've crossed the milestone at the time where you needed to be there. If your first test or your project comes back and you don't have the understanding or the performance that you want to have in class, you want to figure out why and you want to readjust your course. Same idea for milestones at a campus level. Now, in judging our progress, we have to have the ability to measure it, and we need to be able to verify that we've made as much progress as we think we've made. Ideally, this ties back to actual measurements. So in my domain, you can see a gas burning boiler on the left and inset on the right, an example of what a combustion analyzer could tell you. It's some data about what's happening as the fuel is burning. But there are lots of ways to get data that helps us track progress. So it could be individual measurements, it could be some data that's automatically coming in from building monitoring systems, it could be surveys, an inventory of equipment. All of these can help us verify progress. The thing to understand is we want to have a sense upfront of how things are going to be measured and have some agreement on how we'll know if our progress has been verified. That helps us with determining who's accountable. So accountable means specific people or specific campus offices have the responsibility for taking action on pieces of the goal, right? They know how progress will be measured, they understand which part they're responsible for, and they have the authority and the resources to be able to change course if progress is not on track. So if a climate goal doesn't have anyone accountable, It's a climate wish. It's an expression of what we want to happen. But we want to see leaders considering climate-related outcomes when they're making decisions. So that means we want to have decision makers who are accountable for climate-related outcomes. Okay, I want to take one more pause because now we're talking about things that have to be done in coordination with others. So I want you to think of just one person you connected with in that college environment. Maybe a person who made you laugh, helped you think in a new way, supported you in doing something you didn't know you could do. I'll give you a few seconds. Feel free to rest your eyes or stretch. So I'm remembering my first professor who taught me energy science, Edward Perry, and he introduced me to those flowchart diagrams of energy in the US that we were looking at before. Okay, I have one more point of what goes into a good climate goal, and it relates to everything else we've talked about: the planetary perspective, challenge, milestones, measurements, accountability. It's having a well-defined target. So we'll spend the rest of our time until the breakout learning how do we evaluate this. I think a well-defined target should be expressed in 1 or 2 sentences, and it should be explicit about where the campus wants to be in terms of reducing emissions, how that's quantified, and when they want to get there. So in order to kind of see what that looks like, I'll show you a couple of examples of fully specified goals. That just means it's specific enough that someone who's familiar with the kind of terms we're talking about could start to engage on planning for this goal. Having one clearly stated goal is really valuable. There's probably a lot of other documentation associated with them as well. So here's a couple of examples of what that might look like. The first one's a net zero goal. I'll pause for you to read it. Okay, so net zero goals are increasingly popular. Remember, net zero emissions means there's a balance between emission sources and emission sinks. And this one's a reduction goal. I'll pause and let you read it. And know that reduction goals are probably the most popular form of climate goal. The idea is we'll have X amount less or Y% less emissions at some time in the future compared to some time in the past. So let's break these example goals down piece by piece, and you'll see what to look for step by step. Most of the climate goals that you find won't be expressed in this level of detail, and that's okay. You'll know what are the relevant questions you can ask to better understand what they're trying to do. Okay, the first one is declare your system. So tell me specifically what your goal includes, right? If I draw a geographic line around campus and try to capture all the emissions associated with everything physically inside of there, first of all, that's a lot to catalog. That's really hard to do. And we have movement inside and outside of that boundary too. Here's some examples of the kind of things you might see, right? The net zero goal, we have all buildings except the medical campus. Sometimes if your university includes a medical center, those buildings have really specific energy needs. They might be served by different systems. It might make sense to look at them separately. Maybe you see that all buildings on campus are included. That should mean all buildings. So that just know could include buildings that you might not even think of, like a central power station or a central chiller plant for district cooling. And you could also see goals that specifically apply to new construction. That's a common thing to see as well. Okay, so system, what does it apply to? Scope, what kind of emissions am I worried about? So buildings have emissions associated with them at different points throughout their life cycle. The most common part that we isolate and look at is what's called operational emissions. And that just means the emissions that are happening as the building operates day to day. Okay. The other thing that we'll see is that people often want to catalog life cycle emissions. So if I'm doing this for buildings, that means the emissions that were associated with the construction and transport of the building, right? All of those materials that went into it, the operational emissions, and I want to think about how that building is going to be broken down and disposed of or renovated, right? And look at the emissions associated with that too. So life cycle emissions often are tied to a particular standard or framework for cataloging those life cycle emissions. Okay, I want to say exactly what emissions I'm trying to reduce. So the common ones are that we see it in CO2 equivalent. As I mentioned, this GWP 100 means global warming potential over 100 years. That's the most common time horizon that you'll see, but there are other ways to do this. Or you could just look at CO2 itself, right? If you happen to know the bulk of the emissions are CO2, that's an area where it might make sense to just focus on that. Now, I'll take a little bit of a detour for net zero and reduction goals because they have some specific needs in terms of what should be in there. Net zero goals are usually really easy to identify. They typically just say net zero, although sometimes it may not be clear if they mean net zero emissions or what kind of emissions. Okay, and for net zero, again, because we want to get a balance between emission sources and sinks, I have to ask the question, what's the time period over which I want those sources and sinks to balance out? The most common time resolution used by far is a year. So that means you add up all your emission sources for the year, you add up all your emission sinks, and if the sinks are as big as the sources, then you reach net zero in that year. Just like what we saw at the planetary scale, the tricky part of a net zero goal is what do I count as removing my emissions? So a net zero goal that doesn't have steep cuts in emissions isn't in line with those planetary goals. Okay, for a reduction goal, we look for words like reduce or below, and we want to have an amount. So that could be a percentage, it could be an amount in gigatons of CO2 or CO2 equivalent. Okay, here the amount is 40%. And the question is 40% of what? So I want to know, what is my reduction baseline? Where am I starting from when I'm reducing? If I'm starting from 2015 and I want to have a reduction from those levels, I've got to have a campus inventory, right, for the year 2015. And then of course I want to have a deadline. I need to know, when are we aiming to have this done? Because that's how I set up my steps and my milestones that are going to get us there. 2030 would mean I want to have really fast action. 2035 would mean in a little over a decade, I want to be there. So now you'll practice evaluating your own campus's climate plan. You'll look for a goal and see how many of these elements you can find. I've got a flow chart that'll take you through what to look for step by step. Okay, so how this will work is we'll go into a breakout session for the next 8 minutes or so. Before you go, I want you to go to bit.ly/climate goal. I think Hadley's got that in the chat. So have this pulled up. You can also click download and save yourself a PDF copy. You'll start out by saying hi to everyone. Here's my campus. You'll look for a climate goal. And if you find a goal or goals, great. Go through the flow chart and see how many things you can identify by following along. If you can't find any climate goals for your campus, that's okay. Your job at that point is to look for what are the offices on campus that would be responsible for reducing emissions. So looking at those campus offices and trying to understand who's doing what. And it might be the college president's office, might be an office of facilities management or sustainability office if you have one of those. So make sure you have the flow chart open and then go join your breakout team, and we'll see you back here in 8 minutes.
Yes, thank you everyone. Please stick around and take some time to look into your campus goals. And again, if you're not at a college, find one close to you. So let's see, this should be assigned in just 1 second. And here we go. Okay, please go ahead and join your room.
Great, well, welcome back. I hope you had some good discussions. I want to get a sense of what you're running into, what you learned, where you got stuck, and we have some time to chat about that. But first, I just wanted to ask, did you have difficulty finding a climate goal at all? So if you could raise your hand in Zoom, we won't call on you individually, but I just want to get a show of hands sense of how many had difficulty finding the climate goal. Okay. A few hands. Definitely less than half. That's great. Let's put hands down. And let me ask, if you found a climate goal, did you have trouble finding all the details that you were looking for? So if you had difficulty with that, raise your hand in Zoom. Just want to get a sense of numbers. We won't call on you individually at this point. Okay, hands going up a little quicker. Not a ton of hands, but a significant portion of you. Okay. Great. Okay. And so what I'd love to see, you can put this in the chat, is what surprised you or anything that was confusing to you. And I'd love to have, at least from each little team and in the breakout group, maybe you could give one positive finding, like something that you found that you thought was cool or good. Maybe one point of critique, something that could be better about the climate goal or somewhere you'd like to see your campus doing more. Okay, yeah, you have one comment that you have to dig into a climate action plan to actually identify the goal. It's not kind of upfront on the website. That's extremely common. I reviewed goals for professional organizations I'm affiliated with. I saw the same thing. Okay, cool. So we have a student expert on their climate action plan. I love that. Some schools having net zero plans and wanted to discuss how can we do more towards being carbon negative. Yeah, the cuts are a really big piece, even if it's a net zero plan. Calculating a CO2 equivalent, interesting to gain a comprehensive picture. Really glad that you're aware of that. Sometimes people shy away from talking about CO2 equivalents. It's not super complicated. You don't have to calculate them yourselves. And it's really common whenever we're bundling a bunch of different greenhouse gases together. So I want to make sure you know what it is. Okay, anything else? You're also welcome to raise your hand. We will call you on you at this point, but if you want to give us a sense of what your team found, share a positive finding or share a critique. Okay, so one situation where reduction goals were set in 2015, they were exceeded in many years since then, which is cool, but bigger goals were not yet set. Yeah, that makes sense as a thing that would happen. Good place for the university to build on their older success. And the opposite problem. So there's a 2050 goal, which is really far out, right? This is kind of on the scale of our planetary goals, but doesn't have specific steps prepared to get there. So that's kind of hard to see whether that is reachable or not. Okay. Okay, so we had a question also, like, should we be concerned about legacy emissions? We're talking about neutrality, talking about going negative. Legacy emissions seems kind of crucial. If by legacy you mean emissions that have happened in the past, Absolutely. So on a planetary scale, this is a really big deal, right? If we just stopped emitting right now, everything, the planet could continue to warm, right? We have lots of greenhouse gases in the atmosphere that haven't been kind of balanced out by natural carbon sinks. And that's been going on for all of my lifetime, all of your lifetime. I haven't seen, I'm not going to say this hasn't happened, but I haven't seen a campus trying to address their cumulative emissions or historical emissions or legacy emissions. But if anyone run into that and you'd be willing to share in the chat, I'd love to hear about that. What is the consensus on carbon offsets? It's part of your school's plan. There's no consensus on carbon offsets. But I'll give you my take, which is that that's a really hard accounting game to play, right? So if I'm paying for a carbon offset and my argument is that it causes someone else not to make emissions that they wouldn't have made, well, first of all, that's really hard to verify. So there's a lot of good journalism and good science showing that that's very hard to verify. Second of all, it's really not in line with the planetary goal, right? We know what has to happen across the world is that we have to get emissions down really, really small. And so if I'm using offsets as a way to say, like, I'm not going to get my emissions really small, but I'm going to do this other thing. If everyone does that, that becomes really hard to get to a planetary net zero. And so my advice is be skeptical of carbon offsets, but understand that they're well intended and that sometimes a campus doesn't have the resources, whether that's people, money, often money, right? The ability to fit it into the campus plan to get to where they want to be as fast as they want to get there. And so that's when offsets tend to get thrown in. What we emphasize at Project Drawdown is the biggest thing is to make big cuts in emissions and to do it as quickly as possible. Because if I do it now, right, then I'm also saving all the emissions that would have happened between now and 2050. Okay, some talk about goals not being enforced. That's an accounting issue. And yeah, a lot of schools still don't have sustainability offices, so that can be hard. At that point, you know, you need well, even if you have a sustainability office, you need a coalition of different campus offices, right? And then a lot of community colleges have low budgets, and so generating with solar and efficiency take priority right now. I think with the low budget and a lot of restrictions, that makes sense as a place to focus as a start. Cool. Okay, and some great thoughts on landscape being a drawdown platform and not buildings. Thank you for sharing that. Yeah, my expertise again is in energy use in buildings, but I want to acknowledge that it's all of these different sectors. And solving the built environment isn't going to take us to global net zero, right? It has to happen in all these different sectors. Thank you all so much for your participation. Let me give you a couple of thoughts on climate action and a couple of resources, and I'll stick around and we'll try to go through all the questions that have been in the chat, or let you ask questions if you want to do that at the end. So I just want to touch on what does it take to use this new understanding of climate goals, bring it into our real world campus climate action. And a great start is like just looking at the University Climate Ambassadors website. It says we work to systematically implement sustainable initiatives in every aspect of university administration, including curriculum, dining, energy, student life, and long-term planning. So you already have this recognition that it needs to take place across university administration for anything to actually happen, and that a campus itself includes all of these systems that are working together to make campus life take place. And when we look across those, my advice to you is just build your collective effort. So you do need to work across the administration. You also want to have faculty and staff, allies, and advisors. So know that students turn over faster than those faculty and those staff members do. And having longevity and having an understanding of how things really happen on a campus means working with all of those people and having those kind of partners. So goal setting and actions will take place within all of these interlinked systems that we've mentioned. We have curriculum and food systems, and we have long-term planning for the campus that's taking place, that if you can't see it, right, you may not understand why people are making the decisions they're making now, as well as just ongoing, right, day-to-day management, new construction. So a few resources I wanted to point out from Project Drawdown that I think could be useful for your work. First of all is the Climate 101 video series. It's hosted by my colleague, John Foley, and he gives all the climate basics I've covered and more. So you can download graphs, you can see interviews with experts on specific topics, get a lot more information there. You can also see the climate solutions that are available, ready to implement now, and how they're related to different sectors by clicking on climate solutions at drawdown.org. You can download a PDF of the Drawdown review. It's free. It gives an up-to-date overview of this big picture and then shows climate solutions by sector. And you can also start thinking about how are you going to take climate action at work. So this relates to your next talk in this series. And I just want to tell you, our team that's working with the private sector always likes to say, every job is a climate job. So I want you to know whatever your contribution is that you go out and make to the world, climate can be a part of that. So if you check out Climate Solutions at Work, you can see examples of what does a climate job look like in a lot of different types of jobs that maybe weren't previously thought of as climate jobs. We need everyone. And this is how you find me online. Please contact me if you need more information. Project Drawdown is a leading resource for climate solutions. I want to personally be a resource for you as campus climate activists. And you are going to be the professionals who figure out how can we meet some of the ambitious climate goals that are being set right now, whether it's in education, industry, government, or elsewhere. So let us know how we can support you. I want to say thanks to you who are climate ambassadors for doing this important work on your campus. And I'm happy to hang around and we will get through as many questions as we can, but it's really honored to be with you tonight.
Thank you so much, Amanda, for joining us. And thank you everyone for being with us up until the end. And we will be going through the questions from the chat first, but if you are all willing to stick around and ask your own questions afterwards, you can go ahead and raise your hand and then we'll go in that order. Or if you prefer to type something in the chat and have us read that out, we will do that too. But we'll start with a question from Paul. It was about 15 minutes in, and his question was if you know what can be done to remove carbon dioxide from the oceans.
I do not, but I know very good scientists who have expertise in that area who you can learn a lot more from. And so I know if you visit drawdown.org, like you can see kind of a high level overview of solutions that relate to the ocean, but I have no expertise in that area. So like you don't want me to explain carbon dioxide removal from the ocean. Thank you for your interest. And if you need like pointers to resources, feel free to email me for that, but I can't tell you about it here, sorry.
Well, Amanda, do you know that about 40% of the carbon dioxide that goes into the air ends up in the ocean? So
yeah, so that was shown on like one of the overview slides. We see that like about 40% of what's going in currently either winds up in the ocean or in a land-based carbon sink.
and it you know, carbon sequestration and removal from the air, you know, is not going well. And I was wondering if we could take it out of the ocean in a more efficient manner than trying to get it out of the air.
Well, it's definitely true that carbon removal from the air is not far. So we have no noticeable impact from carbon removal from the atmosphere directly right now. Would it be easier to remove carbon from the ocean? I don't know. Just the point that I want to focus on is that it's so much more valuable to drive down what we're emitting, right, than to focus right now on removal, because we know that we have so many things that can cut emissions, that are like available out there technologies that have this potential to really reduce emissions in all of those sectors shown. So that's like by far the most important thing we can do.
Yeah, thank you so much, Paul, for your question. And Eric had asked, can we group efficiency with rejected energy? And that's on the right side of the slide. And that's the graph slide, the estimated energy consumption in the US in 2021.
Yeah, so we can. Those charts come directly from Lawrence Livermore National Lab. I'm dropping the link in the chat. And they present them in this very standard format. And I also have some stylistic and wording things that I would probably tweak if I were making them up from scratch, but they're so well known and like looked at by so many different groups across the world that like I personally wouldn't rearrange them. So anyway, that is what it is. I took it directly from Lawrence Livermore National Lab. And you can see them there for different states, different countries, et cetera. Anyway, yeah, so they're not maybe perfect or organized the way we want, but it's a lot better than looking at that data in a table or on a spreadsheet. I just love that we have a visual of things are moving through the economy.
Michelle, I was just wondering if Amanda could speak more to efficiency. Just your thoughts. I mean, if you could riff on that, is that okay?
Yeah, riff on efficiency, absolutely. This is kind of my jam. So a lot of my research relates to like operational savings in buildings, right? Energy efficiency is the thing, if you're looking at overhauling your built environment for any reason, I want to reduce carbon emissions, I want to reduce my energy bills, I want to make it a place where it's more comfortable and easier to maintain temperature and comfort for the people inside. All of those things, a great place to start is energy efficiency, right? Because if we're using, actually, my number one place to start is conservation. So by conservation, I mean, I'm going to leave this office tonight and I'm not returning until tomorrow morning. So I'm just going to turn my heater off, right? Great. I don't need to use energy to keep this room at temperature if I'm not going to be here. Efficiency, I would say, is related but slightly separate. Efficiency means like I look at my heater and I go, well, can I get a different heater that will keep the room at the same temperature but use less energy to do that? And those kind of things are always a great place to start looking. And so energy efficiency in buildings could mean what I'm talking about. It could mean replacing devices. It could mean I replace the windows so that I'm leaking less heat to the outside. In the summer, I'm gaining less heat from the outdoors. Like these are all efficiency technologies that relate to buildings. I'm 100% pro efficiency. We do see some rebound effects from efficiency, but we still find that it's extremely valuable. It's just making the most of what we have, right? And so if you look at like a conversion to LED lightings in commercial buildings, which is well underway in commercial buildings in the US, we've saved so much energy that you now like would size your heating system differently, right? Because we went from like incandescents to CFLs to LED lights. If you're not a lighting person, all I'm saying is much more efficient lighting, giving me the same amount of light with a very, very small amount of electricity. That's been a huge success. And that's just one simple energy efficiency technology that makes a lot of sense cost-wise. And as people were switching over their lighting systems or building new buildings, they put it in. And then that means the chunk of electricity that we need to make in order to provide lighting in buildings, right, has gone down, right? Even as our square footage goes up, the energy doesn't go up along with that. So that's kind of a cool energy efficiency success story. This was not a plant. Thank you for asking about that.
Yeah, thank you for that question, Eric, and thanks for your answer, Amanda. I think we have about 3 questions left so far, and I'm going to ask the 2 that are campus related first, just since it ties in with the topic of the webinar. Beta asked if you have a good example of collaboration or the best example you've seen of collaboration for a university and its student body, and that with a local government working to reduce campus CO2 emissions.
Wow. I don't. I actually would love to turn that back to the ambassadors and see if you have examples of that working really well. I know that there are pieces of this happening at Utah. I'm no longer at Utah full time, so I kind of can't speak to that situation there. But I know the local government and the campus planners and the campus sustainability office were all like very interlinked and very eager to kind of coordinate plans. And the students were very interlinked with the campus sustainability office, but I wouldn't say it was this like giant magical synergy at the time. But I think those are the three key pieces. Like those are the people who are actually going to be making decisions and affected by what's happening on campus. So if you have great examples you want to share, I'd really love to hear those.
Yeah, I know that's something that's very important, and I think a lot of campuses are working on. The most recent example that comes to mind, actually, we had one of our ambassadors who just left, who's from Maharishi International University, which is based in Fairfield, Iowa. They are the first campus to have a regenerative agriculture major in the country, and I think a sustainable living major as well. And they are just recently making some strides with Fairfield, Iowa government to establish a sustainability committee that has representation from both the campus and from the city. And I think they're making strides to get the county involved as well, but that's even more difficult. And I can also say, I know that at Cal Poly San Luis Obispo, there's different local government officials who are working on campus in different roles, but I don't think they explicitly sit on any sustainability committees. But having that connection where campus officials can sit on city committees and city officials can sit on campus committees, that really is so important. So that is a good question and something that I would love to dive more into. So that's wonderful.
Cool, thanks for sharing, Alan.
And I see Monique has a question. Do you have any advice for what to ask sustainability professionals on how to implement more renewables on campus?
For what to ask sustainability professionals? Maybe if you're still with us, if you'd be willing to unmute, and if you could give me an example of like, what do you mean by sustainability professionals? Because it could be someone who's designing solar PV systems, could be an installer, could be a facility manager. I think we would talk to each of those people a little differently.
Yeah, so I actually have a meeting with one of the campus sustainability managers, and I'm going to ask her certain questions on like solar storage and things like that. But I'm thinking, is there anything like specific I could ask her about what I could maybe like contribute to, or like anything that you would know about that?
Cool. Okay. Yeah. So my first just piece of advice going into this conversation, and this is anytime you're talking to a campus sustainability manager, is just know that they know a lot of the moving parts of campuses that you haven't been exposed to. Because why would you? I found this as a professor too, right? So maybe that you see this building, the roof, that roof that's like sloped south, and you think like, we got to do something solar up there. This would be great. And maybe in the campus plan 2 years from now, there's another building that would shade that, right? So just be aware there are all these things out there that they're like balancing and juggling that you don't know about. And so if they're willing to sit down with you and spend the time, that's a great opportunity to have and go into it with many more like questions and an open mind versus like, I want you to do this and I want to talk you into doing this. Just go into it with, here's what I'd like to see and here's why, and go into it and understand what are they looking at. So what are the criteria you're looking at when you decide whether to implement solar or renewables in a particular place? What would you see as the steps we could take as a campus that would make it easier for you to buy a new renewable energy system or make a renewable energy purchase from somewhere else through a renewable energy credit, whatever that option might be. And so I say, like, do have in your head what you'd like to see from campus, which is like more solar technologies, but also understand why. So if your why is, I want campus emissions to go towards net zero in this decade. So we're really playing our role in, this planetary net zero idea. Then be willing to express that, because it may be that there's a faster way or a cheaper and faster way to take a big chunk of your campus's emissions offline. And it may not be the exact form of technology that you're picturing. So have that in your mind, but have your particular questions. And then just that, like, just what you said to me, ask that, like, what can the students do that would help you? Like, are you interested in having students to crunch numbers? Get an intern who's an engineering student, right? Are you interested in having someone who can do the siting requirements? Talk to landscape architecture. Maybe a student could work with you there, and tell them, hey, I will be willing to take responsibility for getting, students to you, for publicizing this, like whatever you can do that takes that administrative burden off of them, because she may have 7 meetings that day, whoever you're meeting with, right? And anything that you can do, if they know that, hey, there's someone here who understands what I'm talking about, who wants to see change in campus and who's going to work hard to do that, they'll start like little by little letting you do more and more of that if there's a good place where you can plug in.
That's such valuable information, and something that I know our university climate ambassadors are dealing with on a regular basis. Just how do you talk with those sustainability managers or facility managers? And that is the very first step, is just really understand where they are and what their needs are.
Yeah, if they're at the table with you, like, you've won, you're on the way. And then just come to them to learn from them.
Yeah, and Monique, who asked that, is one of our great ambassadors. So thank you for that, Monique. And I wanted to jump back because I want to make sure this person's still here, and I want to make sure we don't leave their question unanswered. It's not tied to campuses, but Malia said that there are natural carbon sinks, but are there any natural sinks or processes of removal for other greenhouse gases?
Wow. I'm also going to have to give you a big fat, I don't know, but I have friends who are climate scientists. If you want to dig into that concept, that I can point you to. But yeah, my expertise is energy and buildings. And so I know like the climate big picture, and I don't want to just go completely outside of where I'm an expert. Thank you for thinking about that, though. That's really interesting.
I saw that question. I thought it was fascinating too. Charlotte had asked, the consulting group that's helping my school reach carbon neutrality hasn't been very good at communicating to students. Their presentations can be hard to understand from an outsider. Do you have any resource advice on this that I could use to improve communications to students on our plans?
Wow, I love that. So I was in consulting, and the thing to know about that is, in any sort of job where you have to go in and assign all of your hours to projects, you're kind of like a lawyer, like you're kind of worried about billable hours. And I say this just so you can understand what the process is that they're facing. And so if they don't have a project that says student outreach that they can bill time to, then that's their personal time, right? I don't like that that's the way it is, but that's the way it is. And there's a lot of people in energy consulting who do that work. There's a lot of consulting companies that want to support that work. But if it's not expressly in their plan that they are going to coordinate with students, they have some contract with your university. And if you're trying to get them to do extra stuff, like, you're just going to have a harder time. That's just the fact of it. So what I hope is that you at least leave here knowing the key terms. So things like carbon equivalent, things like building efficiency, things like how do decarbonization and electrification relate to climate goals. I hope that helps in making sense of some of the stuff that you're talking about. But yeah, if I, as an energy consultant, give a presentation to someone who is, a facility manager, I'm going to assume that they're at the same level of knowledge, and I'm just going to start talking at that level. And so the options, I think, are having them give presentations that are targeted towards students, And a lot of people like to do this, even engineers, right? We're kind of known as being introverts or unfriendly, but I know so many engineers that love doing outreach and love talking to students because they love their field and want people to understand and get interested in it. So having a presentation that is like expressly supposed to be accessible to students is probably your best option. But if you can't do that, like one thing I would ask is just through your university interface, say like, can I review these presentations? Like if they're sending them to you a day in advance, can I take a look? Can we have a little explainer? So maybe through the sustainability office, there's an explainer with the key terms that you keep seeing popping up that they're assuming you understand, right? Because they're assuming you're at a certain level. And maybe like you could help create a glossary of what those things are so that now other students have a pathway into figuring out what's going on in those presentations. So I don't have particular resources on improving communication to students for you if they were coming to me as a practicing engineer. And they're welcome to email me too. You can give them my email if they're interested. I can talk about how I change my talks when I'm going from an audience of engineering students to other students, or from a group of scientists to a group of students. There's some specific techniques that you can use to do this. But I think like from your side, I know that's hard. And I just want to say, I respect you like jumping in, going to these presentations, trying to make sense of it. They probably weren't supposed to make sense to you. They were probably targeted at a different person, and that's okay. Like learning to look things up for yourself and learning to ask questions when you have a question is also really valuable. So, you know, even if there's a lot of people, like anytime you ask a question, there's a bunch of other people wondering the same thing too. So take that as like your own, like, yeah, my advice maybe is take that as your own impetus to be willing to speak up and be willing to like be the one who doesn't know something, which I also hate being. But be willing to do that so you can get more information out of the people who are doing this consulting, because they're doing it for you. Like they're doing it for the student body ultimately, but they're not answering to you. So that makes it a little tough.
That's all very important perspective, which I think we all appreciate. So thank you for that. Yeah, Charlotte says thank you so much. And then I think this will be our last question, at least for the recording. There's one small follow-up question from one earlier, but as a last university question, so we can let you go, Vita asked again, what are university priorities right now, and why are we focusing on those things in particular at this time? Maybe you could touch on energy priorities that campuses are taking versus, again, what they should be taking.
Well, I just want to say, I mean, that's a great question to take to your sustainability people. So I wouldn't assert that universities as a whole are doing this, and they ought to be doing this. The only place I'm comfortable doing that is I can say like a lot of climate goals aren't really well specified. There's no reason they can't be. We've just like walked through how they can be. That would be a great start, because then it's clear to everyone like what we're planning for. But each university's priorities ideally would be set by their own inventory. So you look at each of the sectors, you meaning the campus, right, would look at each of the sectors where emissions happen and try to estimate how many of my campus's emissions go into each of those sectors. And maybe you do it by greenhouse gas as well. Maybe you look at carbon dioxide and methane and refrigerants, right? And then you choose the places to focus based on an assessment on actual data that relates to that particular campus. So no two campuses' climate plans should be the same. And I don't want to redirect everyone's focus. And, you know, I don't want to say like every campus needs to worry about energy efficiency in buildings. I think every campus does, but I don't know if that should be every campus's top priority, right? Because I don't know their situation.
That actually wasn't my question. This was my advice to the woman that asked, what should I ask my sustainability manager when I go into that meeting? And my suggestion was you should ask, what are the campus's priorities right now and how did we choose them? Just so you know where they're coming from. That's all. Thanks.
Oh, yeah, great. Totally agree. Good question.
That works too. Thank you. Well, I know we're 20 minutes over, and those were our main big questions for now. So thank you very much, Amanda, for joining us. Thank you everyone else for sticking around 20 extra minutes as well. And yeah, thank you all for taking the time to learn more about electrification, decarbonization, what makes a good climate goal. And thank you again, Amanda, for just giving such a wonderful presentation and bringing your expertise to the table. It's been wonderful. And for everyone who's still here who isn't involved in our Climate Ambassador program, I've shared the link to the Ambassador program in the chat if you're interested in getting involved and connecting with students from other campuses. And we do have another webinar next week at the same time called Equipping Students to be Sustainability Leaders in the Workplace. So I will send a follow-up email with a link to this recording and the link to that presentation to register as well. So thank you all for that and have a wonderful rest of your evening.
Great. Thank you.